Okay, I can see a few people have joined, so we might get started just to keep to time. So hello everyone. Thanks again for joining today's latest HashiCorp snapshot titled Connecting Apps Across the Cloud, which will be presented by Senior Solutions Engineer Dave Wright. So today Dave is going to show you how we deploy Consul to connect multiple cloud platforms. He's got some slides and a great demo that he'll take you through in a moment. But first of all, I just want to run through some housekeeping. Just want to let you know that this session is being recorded, and a recording will be made available within the next day or two. We'll send out an email with the link. And today's demo will last about 15 minutes. And to keep to the 15-minute time frame, we won't have time to answer questions as we go. But please do submit your questions to the chat tab down there at the bottom of your screen, and we'll get to those answers at the end of the session. And with that, let's go ahead and get started. Over to you, Dave.
Thanks, Pete. So in today's session, we're going to talk about connecting clouds and some of those challenges. One of the things we're going to do is look at the challenges of the modern connectivity and why modern networking is actually challenging, how it differentiates from the past. We'll look at how to actually overcome that with the use of Consul. We'll look at a specific feature, a couple of features that really help enable that multi-cloud component. And then we'll take a look at a demo that I've put together that actually kind of really walks through that whole process and just highlight some of those steps. So if we take a look at why modern networking is a challenge, I think it's a good place to start just to kind of set a baseline. And what we're talking about is, if we look back in the past, traditional networking was very much under your control. You had a very defined realm that you were the master of. You had a point between internal and external that you could define very clear security barriers. You could allow which traffic would go in, which traffic was going out. And then within that sphere of control, you could separate VLANs, you could create routing rules to actually steer traffic. You knew who was coming in, you could create remote access, you could join over dedicated links between two existing data centers. Now, when you take that and add into the mix environments that you don't have any control over, so as you start consuming cloud platforms, as you start consuming as a service mechanisms, as you look at containers or serverless, in those environments, you don't have any of those control mechanisms. And to add to that complexity, you then have things such as they're only short-lived, how do I register them? Lots of these are being driven by application teams. How do I interlink those services? And how do I fit those into my existing environment? And the way that we do it and the way that we approach that is with Consul. And Consul has three key elements that really clearly address how to solve those challenges. The first of those is our service registry. And so Consul acts as a single source of truth that actually allows you to register those services. And because it uses a mechanism underneath, which is DNS, that mechanism allows you to then either forward that on to existing DNS infrastructure or to actually be slave from existing DNS. And so now you have a mechanism to talk between the new and the old world. And once you've started to register those services and know where they are, you can then actually start to allocate where those services should be connected to and allow other resources to access it. The next step in that journey is then also the service discovery. So once you have the registration, now you need to be able to tie, how do I automatically discover these new or short-lived services? And this is where Consul Connect and the ability for an agent to be injected into a Kubernetes cluster, for example, and automatically register with our cluster and feedback that service. And so now you have a single source of truth, you have a mechanism to be able to register, and then leveraging the service mesh, you now have a mechanism that ties all these things together. So the service mesh allows for those services that were registered to be able to be, or discovered, to be able to communicate with each other over a mutual TLS. And so now you have a mechanism that can tie different elements together in the new and the old world and automatically register them and connect those apps together. So what we're fundamentally talking about is making sure that console acts as this single control plane. And in that component within a data center, it can then actually work in some of the traditional space that standalone elements would. So as console as a cluster, it can allow you to actually do load balancing. You can actually start to do some proxying components. So you can proxy in between different networks. It has a firewall or security component with our intentions, which allows for specific rules as to what services can be connected. You can bring services in, so you can bring in services such as API calls into those into your application, or you can interact with external sources like RDS, for example, and bring services out of the existing mesh. And so all of these components go together to create this single control plane. Now, once you have a single control plane, what you can then do is link those elements together to create an overarching control plane. So now you have, using our basic federation, so our WAN join capability, which allows both of those clusters to be joined together. And now those two clusters could share resources. And within that structure, you then have geo-specificity. So that allows you to actually say, I know where this resource lives, I know how to divide those resources up. The other key element that we were looking at is also the mesh gateway. And so the mesh gateway is a mechanism that allows for traffic to be routed out. It uses the SNN headers to actually then steer to another gateway component and uses mutual TLS between those 2 points to actually allow for the applications to communicate. So in that multi-data center component, we have our WAN federation that allows the resources to know each other, and our mesh gateway that allows them to connect together. So if we take a look at what our application or our demo is going to do, and later on there is a link to this repo if you want to actually download it and try this again, or there is also a learn mechanism that sets up the console connect. So you could use either one of those mechanisms to play and discover this yourself. But fundamentally what we're doing is we're using this console connect element here to inject. So this is run on a Kubernetes cluster. When it stands up, we inject the connect agent into it, and that auto registers with console. We then also use the service upstream mechanism to define where our services will talk. So our Vault mechanism here is local, and our MariaDB is actually specifically only in GCP. So even though we would deploy our application across different data centers, the actual database and records will only live in one particular cloud provider. Now, this also opens up some interesting challenges around using data sovereignty and how do you protect that. And so we leverage Vault to actually encrypt that local data set so that only data within that cloud can be read from the database on the back end, even though the applications are sharing the same database and the same schema. So if we just take a quick look through that session and how and what will actually happen, our application will actually make a call to its local proxy point. From that local point, it will then make a sidecar call into our mesh gateway. And that establishes our TCP and TLS session. Our local gateway then looks up where it needs to go, talks to the mesh gateway that is corresponding to that, and then our corresponding gateway on the other data center then makes the routing decision based on that incoming header. It passes it to that local sidecar proxy in a reverse of what we've just done, and then starts a mutual session between those two proxies. Then we make a check to make sure that there is a security role. So this is our intention and that firewalling element that I talked about. And this then checks to see whether we can actually make that local connection. If we can't, it will send a reset. If we can, it will send off a local connection to the local host port on the service and establish that data connection. And now our applications can talk. So if we actually look at this in practical terms, what we're talking about is being able to make fundamentally DNS requests between these components. So if we just take a look here, you can see what we're doing is making a DNS request across our different systems. And here, MariaDB responds for our GCP. However, if we look in AWS, we can't find it. However, what we can do, and this is where that geospecificity comes in, I'm having trouble with my words, we can see that console, our transit app, which isn't up yet, can be specific to a particular area. So if we just take a look at deploy an item. So while that's deploying, let's have a look at that in a more visual way. So you can see here that in our GCP, we don't have our application deployed yet. If we look in AWS, it's not there yet. AWS, in Azure, if we go back to GCP, now you can see our application is automatically registered and is available. If we then look in Azure, now our application has been deployed, and the same in AWS. And you can see clearly that in those other data centers, there is no database. There is only that database here in the MariaDB component. So if we just take a look at if we just take a look at our Azure, so Azure usually spins up reasonably quickly. So let's just change our context into Azure. If we can get our service to have a look. So here's our transit app service address. Let's see if our app is up. Right, so our app is up. Let's take a look at some records. So I pre-populated some of these records just for time, but you can see here that we can see the Azure records, but we can't see anything for any of the other cloud providers. And if we look at our database view, you can see that we do actually have records for them, and they are encrypted using the Vault string. So why don't we have a look at what's happening in one of the other clouds? And hopefully, if we do the GKE, because that's usually reasonably fast. And then we do our get service. So here is our K8 app again. So let's look at that app. 4,000. And all of these are available in the README when you actually run through it. So you can copy this quite easily. Now, if we look at our records in GCP, you can see that we can actually see the GCP record, whereas in our Azure, we couldn't. You can see it, but you can see the Azure one. And here we have localization. And again, this is all through the use of Vault and integrating those two things. So if we go back to our console and we actually do that DNS request now. So if we look at our service here, you can see that our service will respond with an AWS specific component. Now, if we change this to GCP, app will respond with the GCP address. And you can see that difference between those responses. So let's just to round this out, let's see if we can get AWS to come up now. Their DNS is usually a little bit slower, but hopefully it will be working. If we use their domain names. DNS 45,000. Yeah. And now you can see the records. And so now you have all three with individual records that can only be read with that local Vault instance. These mechanisms are connected using console. So you can see that the database only is living in GCP and all of those records are stored in one single place. And yet we have our application deployed across multiple environments and multiple different cloud providers. These clouds are also across different regions. So I have one in the US, I have one here in Australia, and I have one in Asia. So the whole mechanism is using those fundamental elements to put together. It uses DNS and our service definition. So Vault is defined as a local service. The MariaDB is defined as a remote service specific to GCP. And with that, our apps can now actually find and connect to those different services. You can also see that our console servers are built in our 3-node cluster here and Vault in our 3-node cluster there for resilience. And our mesh gateways have been deployed as 2 instances and have been federated across each other. So with that, that's basically heading back into a thank you. So what I'd like to do is thank everybody for coming. This repo is basically that full demo. So in it, there are 3 scripts. All you have to do is follow the README. The first script is a deploy. The second script is an app migration. So you can actually do a variation of this where you deploy the application first of all, and then move the other 2 apps to stand up. And then there is a complete destroy. So it will actually do and destroy all of those. All of this is automated using Terraform, and all of it is run within the 3 managed cloud Kubernetes components. There is a cost associated with those when they stand up. Also, go into Learn, look up for Mesh Gateways and Console Connect, and for WAN Federation. There are examples of all of those and how to deploy all of those with use cases and run-throughs on the Learn site. And obviously, please stay tuned and sign up for the next snapshot series. With that, back over to you, Pete.
Thanks, Dave. Thanks for that. Nice demo. Very good work. Now, I'm just looking to see if we've got any questions. I think I can see one in the Q&A tab for you, Dave. Can Console complement AWS Private Link, or are they mutually exclusive?
So with the Console will need an underlying connectivity mechanism, whether that's routed out through the internet or over private links. So yes, it will complement a private link if you have set up the routing link and permissions correctly to allow it through. It uses, there are 4 defined ports now as of 1.8 that we consolidated down to make it easier for security concerns to actually allow those connectivities to happen.
Great. And just looking to see if there's any others. Folks, if you do have any questions, please pop them into the chat while I close this out. Alternatively, as Dave mentioned, you can contact him a myriad of ways through those contact details you can see on your screen there. I think I've just seen another question pop in. Okay. Dave, could you get into a bit of detail about how K8's transit app get deployed to all 3 DCs?
Yeah, so the script that runs effectively just does a app deploy. So it's a compiled Python app that is uses the standard Kubernetes kube control apply to deploy that file as an application. All I've done is wrap a bash script around it that allows for all 3 of those to run through, and done some contextual switching between each of the Kubernetes clusters, because obviously you need to do the kube control for each individual cluster set. I just have to context switch between those. And so that script just made it easier and faster for demonstration purposes to be able to do that.
Great. Okay, just looking, I can't see any other questions in queue, so we might wrap it up if everyone's good with that. Yep. Okay. Like I said, you can contact Dave on those details there. So that brings us to the end of the session, folks. We hope you found it useful. And as I mentioned at the top of the call, this session was recorded. The recording will be made available on our website soon, and you'll also receive an email with a link to that recording. And if you like what you heard today about Console, you can visit our Learn site at learn.hashicorp.com. Again, that link is showing on the screen there. So do have a look at that. And also don't forget to register to our next snapshot, which is on Nomad, First Class Federation with Nomad, which will be held on the 6th of October. And you can register at that link down there, hashicorp.com/events/series/snapshots. And like I said, you can look at those URLs when we send you the recording if you don't take it down now. So that brings us to the end. Thanks again for joining, and big thank you, Dave, for your presentation and demo. Very nice work. And yeah, hope to see you all on the next one. Bye for now.